welcome back, dear students. So today we are going to discuss a special type of integrals. Last time we completed methods of integration. Total 3 methods we have done. First method was substitution method, second method integration by parts, and third method integration by partial fraction. So after completing methods of integration, there are 3 methods. We have completed all 3. Now today I have a special type of integrals. Now question arises, are we going to study any new method of integration? Answer is no. Integration has only and only 3 methods: substitution, by parts, partial fraction. Today I am going to show you some special integral. In the name of method, they will have use of either substitution, by parts or partial fraction. We will see some special integrals जो आपको बार बार प्रॉब्लम्स में दिखाई देते हैं. मेथड के नाम पे कोई नया मेथड मैं आपको नहीं बताऊंगा. जो इंटीग्रल मैं आपको दिखाने जा रहा हूं, they will have either use of substitution, by parts और partial fraction. जिन इंटीग्रल की आज मैं बात करूंगा कि अगर वो या उनसे मिलता जुलता इंटीग्रल आपको दिखाई देता है, देन हाउ विल यू इनिशिएट, दैट आई एम गोइंग टू टेल यू. एंड दीज स्पेशल इंटीग्रल यही आपको बार बार इंटीग्रेशन की प्रॉब्लम में घूम फिर के दिखाई देते रहेंगे. सो फर्स्ट वन इज इंटीग्रेशन ऑफ x इंटू एफ डैश एक्स प्लस एफ ऑफ एक्स dx is equal to x into f of x plus c. Fine. You can learn this result whenever we find integral having expression x into f dash x plus f of x. We can directly go with the result, that is x into f of x. For example, we have problem integration of x cos x plus sin x. Now, if I call it f, then it is clearly f dash. So, what should be the answer? X into f of x plus c, that means x sin x plus c. Getting it? So, our answer is x sin x plus c. More problem. Now I have integration of x plus sin x divided by 1 plus cos x. Last one was the direct problem where this form x f dash x plus fx directly visible, but here in this problem you can see direct this form is not visible. So we will do some calculation. I am writing sin of x 2 sin x by 2 cos x by 2. In the denominator, cos of x 2 cos square x by 2 minus 1. What I have used? I have used formula of sin 2 theta cos 2 theta. Sin 2 theta का formula, cos 2 theta का formula. So now it is x plus 2 sin x by 2 cos x by 2 whole divided by 2 cos square x by 2. Now we can separate integral in 2 parts. The x upon 2 cos square x by 2 plus 2 sin x by 2 cos x by 2 divided by 2 cos square x by 2. So now it is integration of x into sec square x by 2 plus tan of x by 2. Now we should check. If I call it f of x, then is it f dash x? Answer is yes. If I call tan of x by 2 function, then clearly sec square x by 2 divided by 2 is f dash x. So what's the answer? X into f of x plus c, that means x into tan of x by 2 plus c. So our answer, x into tan of x by 2 plus c. Are you getting it? So I have written first special integral, that is integration of x f dash x plus f of x. Direct answer, x into f of x. So whenever it is possible to convert given integral in this form, we can use direct result. Now special integral number 2. Special integral number 2, and it is very important one. It is integration of e to the power x time f of x plus f dash x. Result is e to the power x into f of x plus c. Integration of e to the power x time function plus derivative. Answer, e to the power x into f of x. Problem of integration where you find e to the power x, 99% chance may be of this integral. You may have this integral. Whenever integral has e to the power x, always try to find this special integral. Can we have function plus derivative in multiplication with e to the power x? If yes, then direct answer, e to the power x and f of x. Now, in a school exam, they may ask proof of this integral. So, I am doing that. I am starting with left hand side, which is integration of e to the power x time f of x plus f dash x. I am separating integral in two parts, e to the power x into f of x plus e to the power x into f dash x. Now, here I am going to apply by parts. Integration by parts, where e to the power x second function and f of x first function. So now using the formula of by parts, first into integration of second minus within an integral sign, differentiation of first into integration of second plus integration of e to the power x into f dash x. Now it is f of x e to the power x minus integration of f dash x e to the power x plus integration of e to the power x into f dash. Clearly we can cancel these two. So e to the power x into f of x. Okay. In a school exam, they may ask proof of this special integral. In a problem of integral, yes, direct use of result is allowed. You have an integral where you are finding the form e to the power x time function plus derivative. Direct result you can use. You are allowed for that. I am taking the problem. Integration of e to the power x time x minus 1 upon x square. One can write it e to the power x time 1 upon x minus 1 upon x square. Is it? Now, with e to the power x, I have two terms, but the form required function plus derivative. So now there you may have confusion. There is minus. But my dear, try to understand, if 1 by x is function, then minus 1 by x square is clearly f dash. इसको ही मैं यहाँ पे लिख रहा हूँ, dy by dx of 1 by x क्या होता है, माइनस 1 by x square. dy by dx of 1 by x is minus 1 by x square. So we can club this minus sign in the name of derivative. If the first term is function, then second term with minus sign is clearly f dash. So integral has form e to the power x time function plus derivative. So answer e to the power x f of x plus c. That means e to the power x into 1 by x plus c. Are you getting me? We directly using the result of special integral, we are able to solve the problem. e to the power x time 1 plus sin x divided by 1 plus cos x. Now, here in this problem, right now if we separate numerator in two parts, then function plus derivative is clearly not visible. For example, if I write it as e to the power x time 1 upon 1 plus cos x plus sin x upon 1 plus cos x. Now, you may have problem in deciding function and derivative. So, if we do some manipulation here, that is formula. From the trigonometry, formula of cos 2 theta, formula of sin 2 theta, formula of sin 2 theta, formula of cos 2 theta. So now, e to the power x time 1 upon 2 cos square ऊपर आके sec square x by 2, and here after cancelling all the terms tan of x by 2. Now my dear, you can check function and derivative. If I call it f, then it is f dash. So once again I have integration of e to the power x time function plus derivative. My answer e to the power x f of x plus c, and here f of x is tan of x by 2. So that's my answer. Next problem, integration of e to the power x time x square plus 1 divided by x plus 1 whole square. Fine. वीडियो को पॉज करिए. आप में से जिसको लगता है कि दे कैन डू दिस प्रॉब्लम, दे शुड ट्राई फर्स्ट. आई विल कंटिन्यू द सॉल्यूशन ऑफ दिस प्रॉब्लम, बट पहले आप खुद से ट्राई करिए. वीडियो को पॉज कर दीजिए, प्रॉब्लम ट्राई करके देखिए. नहीं बनता है देन वापस आके सॉल्यूशन देखिए जो मैंने किया. इन द न्यूमरेटर आई एम राइटिंग x square minus 1 plus 2, which is allowed. Now, e to the power x time x minus 1 x plus 1 divided by x plus 1 whole square plus 2 upon x plus 1 whole square. So, integration of e to the power x time x minus 1 upon x plus 1 plus 2 upon x plus 1 whole square. Check करिए. That can be written e to the power x time x minus 1 upon x plus 1 plus 2 upon x plus 1 whole square. Now, दो लीनियर का रेशियो, इट इज रेशियो ऑफ टू लीनियर. कुछ दिन पहले मैंने आपको बताया था दो लीनियर का रेशियो डिफरेंशिएट करने पे क्या मिलता है? कांस्टेंट अपॉन डिनोमिनेटर स्क्वायर। दो लीनियर का रेशियो है ये, और यहां पे क्या रखा है? डिनोमिनेटर स्क्वायर। आप चेक कर लेना, इफ वी कॉल इट f, then this whole term is f dash. So once again we have formed e to the power x time function plus derivative. So our answer, e to the power x f of x plus c, e to the power x time x minus 1 divided by x plus 1. So in this way, answer e to the power x time x minus 1 upon x plus 1. Getting it? Directly function plus derivative was not there. We have done some manipulation. Minus 1 plus 2 in the numerator. Then separating numerator, we have clearly function plus derivative. Is it? Next is integration of ln of ln x plus 1 upon ln x square. Fine? Student, इस तरह का प्रॉब्लम ज्यादा कंफ्यूजिंग होता है. There is no e to the power x. If I talk about special integral number 2 here, तो you will say कि e की पावर x तो दिख ही नहीं रहा. So याद कर लीजिए, whenever there is log x, then we should try substituting log x is equal to t. Your integral has term of log and no standard method is clear to you. एक चांस लेके देखिए, log को सब्स्टिट्यूट कर दीजिए. Why I am saying to substitute log? अगर आपने log ln x को t लिया है, ln x का मीनिंग क्या होता है? ln x has meaning log of x to the base e. ln x का मीनिंग होता है log x to the base e. Now log x अगर t है तो x की वैल्यू क्या होगी? e to the power t from the property of log. So integral has log x, substituting log, there is chance of getting special integral number 2. How? Let's see. Since we have done substitution, so we will have to do differentiation on both sides with respect to x. That means 1 upon x is equal to dt by dx. It implies that dx is equal to x dt. Now this integral, substitution and the value of dx. Integration of ln t plus 1 upon t square, in place of dx, x dt, which can be written ln t plus 1 upon t square into e to the power t dt. हाँ, कैसे आया ये? Log x to the base e is equal to t will imply x is equal to e to the power t. Log x equal to t will imply x equal to e to the power t. So that's the reason इस x की जगह क्या आ गया? e to the power t आ गया. Now because of exponential term e to the power, now you may think about special integral number 2 here. Special integral number 2 here, which is e to the power time function plus derivative. But do we have that here? E to the power t time log t plus 1 upon t square. अभी भी कहानी में ट्विस्ट है. Our special integral says e to the power time function plus derivative. If I call ln t function, तो ln t का डिफरेंशिएशन क्या होगा? 1 upon t. जबकि यहां क्या है 1/t². Try to understand, it is not function plus derivative. Some more manipulation required here, and I am writing ln t plus 1/t minus 1/t plus 1/t². Is it? That is allowed or not? 1/t minus 1/t. What's the benefit? E to the power t times ln t plus 1/t minus e to the power t times 1/t minus 1/t². Now I am separating integral in two parts. E to the power t times ln t plus 1/t minus integration of e to the power t times 1/t minus 1/t². Now check it. If I call it f, then it is f dash. If I call it f, then including minus sign, it is f dash. Here also f plus f dash. Now some may have confusion here. Some of you may have confusion here कि बीच में माइनस है तो ये f plus f dash कैसे हुआ? Try to understand, minus is the part of derivative. 1/t का डिफरेंस माइनस 1/t². तो ये जो बीच में आपको माइनस दिख रहा है दैट इज ऑन द पार्ट ऑफ डेरिवेटिव. इट इज अल्टीमेटली f प्लस f डैश. जिनको कंफ्यूजन हो रहा है उनके लिए मैं यहां फिर से लिख रहा हूं. डिफरेंशिएशन ऑफ 1/t होता है माइनस 1/t². Differentiation of 1/t is minus 1/t². So it is f plus f dash. So now we will write e to the power t into ln t minus e to the power t into 1/t plus c. I have applied result of special integral number 2, which is e to the power into function. E to the power into function. Now, final answer we will give in terms of x. So, put the value of t. So, e to the power ln x, ln of ln x minus e to the power ln x into 1/ln x plus c. Now, e to the power ln x, how much? X. So x into ln of ln x, e to the power ln x, x upon ln x plus c. So that's the final answer. X time ln of ln x minus 1/ln x plus c. That is our final answer. Getting it? Initially, there was no e to the power in the given integral, but integral had ln x. We have substituted ln x. Then we have got an integral where special integral number 2 can be possible. Is it? चलिए एक और प्रॉब्लम करते हैं. दिस वॉज इन एग्जाम ऑफ AIEEE, विच इज ओल्ड नेम ऑफ JEE Main. इंटीग्रेशन ऑफ ln x minus 1 divided by 1 plus ln x square whole square. Now student, this problem you should try first. Fine. Similar kind of logic we can have here. Problem has no e to the power, but problem has ln x. So we should substitute ln x. आगे जाकर there may be chance of special integral number 2. Try करिए. I am doing it. So we will start with substitution ln x equal to t. ln x equal to t means log x is equal to t. Now differentiation on both sides. So 1 upon x is equal to dt by dx. It implies that dx is equal to x dt. Now our integral substitution and the value of dx. What will they give? T minus 1 upon 1 plus t square whole square in place of dx x dt. So t minus 1 upon 1 plus t square whole square e to the power t dt. Fine. We have got e to the power in place of x. Log x is t. Log x is t. We have log x is equal to t. It implies x equal to e to the power t. That's the reason x has e to the power t. In place of x, e to the power t. Now, our integral is e to the power t times t minus 1 upon 1 plus t square का whole square. Integration of e to the power t times t minus 1 upon 1 plus t square whole square. Clear? Now question arises, do we have special integral number 2 here? Answer है अभी नहीं. हमारा स्पेशल इंटीग्रल नंबर 2 क्या होता है? e की पावर के साथ we should have function plus derivative. What's the meaning of function plus derivative? There should be two terms where one can be called function and other its differentiation. So that possibility is not right now. But if we do some manipulation, for example, in the numerator I have opened a square, but in denominator I am not opening the square. We have power 2 in numerator as well as in denominator. So I have opened power 2 in numerator using the formula a minus b whole square. मैंने numerator में apply कर दिया a minus b whole square, but in denominator मैंने कुछ भी नहीं किया. Now I am separating numerator in two parts. So it is e to the power t times t square plus 1 divided by 1 plus t square whole square minus 2t divided by 1 plus t square whole square. So integration of e to the power t times 1 upon 1 plus t square minus 2t divided by 1 plus t square whole square. क्लियर? अब आप चेक करो, क्या अब फंक्शन प्लस डेरिवेटिव है? यस है. इट इज. चलिए अभी तक आप में से कई को माइनस से अगर दिक्कत हो रही हो तो हियर इन दिस प्रॉब्लम आई एम क्लेरिफाइंग द माइनस साइन and I'm writing it plus minus 2t upon 1 plus t square whole square. बताइए, minus can be written plus minus, is it? No. If I call it f, then this is f dash. So now we have e to the power time function plus derivative. So special integral number 2, what should be the answer? E to the power into function. Now final answer in terms of x. So in place of t, log x to the base e. In place of t, log x to the base e. final answer one can write e to the power log x. E to the power log x will be what? X. So the final answer is x divided by 1 plus log x whole square plus c. This is our final answer, x upon 1 plus log of x square plus c. So e to the power log x is x. So our final answer, x upon 1 plus log of x whole square plus c. Is it? So we are talking about special integral number 2, and I have already told you it is important one. इसके ऊपर प्रॉब्लम बनता है एग्जाम में. Now students, we have special integral number 3. What is special here? How to remember it? Denominator has quadratic, denominator has root over quadratic, or numerator has root over quadratic. If any of these three pattern you have, then what will you do? Convert ax square plus bx plus c into perfect square. I hope you must be aware how to make perfect square. Convert quadratic into perfect square. फिर भी जिनको अगर ये परफेक्ट स्क्वायर बनाना नहीं आता है, उनके लिए मैं डायरेक्ट फॉर्मूला लिख रहा हूं. राइट ax स्क्वायर प्लस bx प्लस c इज इक्वल टू a टाइम्स x प्लस b बाई 2a होल स्क्वायर प्लस c माइनस b स्क्वायर बाई 4a. You will get your quadratic in form of perfect square. To handle these integrals, what to do? Convert quadratic into perfect square. In lower classes, perfect square बनाना सिखाया जाता है. If still you don't know about that, go through this formula. Write your quadratic as a times x plus b by 2 whole square plus c minus b square by 4a. You will get quadratic in terms of perfect square. So, क्या बोला? Convert quadratic into perfect square, then use standard formulae of integration. Okay, two things we have to do. We will convert quadratic into perfect square, then we will use standard formulae of integration. Fine. I am taking the problem. I have integration of 1 upon root over 3 minus 2x minus x square. Is it? How to make this problem? Special integral number 3, we will convert quadratic in terms of perfect square. So, using the formula minus 1 time x plus b, b is minus 2 divided by 2a, minus 2 whole square plus c 3 minus b square by 4a, that is 4 upon 4a minus, so now it is 1 upon it is 1 upon minus time x plus 1 whole square, and this is 4 or 4 minus 1, 4 by 4 1, और ये माइनस के माइनस 1, 3 plus 1 4. ये पूरा हमारा स्क्वायर रूट के अंदर है. सो नाउ 1 upon root over 4 minus x plus 1 whole square Is it? I will write it as 1 upon root over 2 square minus x plus 1 whole square. Now, अब एक फॉर्मूला याद करिए, स्टैंडर्ड फॉर्मूला 1 अपॉन रूट ओवर ए स्क्वायर माइनस एक्स स्क्वायर का रिजल्ट क्या होता है? साइन इनवर्स एक्स बाई ए. वी नो द स्टैंडर्ड फॉर्मूला 1 upon root over a square minus x square sin inverse x by a. Now the same formula we will apply here. Same formula we will apply here. Root over a square minus x square. So what's the answer? Final answer is sin inverse of x plus 1 by 2. Is it? That's my answer. Clear? Okay, now I am coming to special integral number 4. Special integral number 4 and it is integration of linear px plus q divided by quadratic x square plus bx plus c, or integration of linear px plus q divided by root over quadratic root over ax square plus bx plus c, or integration of linear px plus q into root over x square plus bx plus c. Fine. If we have any of these integrals, first of all, check the difference between this and the previous one. In the previous one, there was only quadratic, but this time linear upon quadratic, linear upon square root of quadratic, linear into square root of quadratic. What should we do? Write px plus q is equal to lambda times differentiation of quadratic plus mu. Get lambda and mu comparing coefficients. Replace px plus q in the integral by expression in terms of lambda and mu. Now separate integral in two parts such that one has lambda and second has mu. One has lambda, second has mu. First part will have substitution method. First part will have substitution method. First part will have substitution method, and second will be special इंटीग्रल नंबर 3। चलिए नोट करिए। वी विल राइट p of x plus q is equal to lambda टाइम डिफरेंशिएशन ऑफ क्वाड्रेटिक प्लस म्यू, लैम्डा म्यू निकलेंगे, देन px प्लस q को वापस हम रिप्लेस करेंगे इंटीग्रल में, इंटीग्रल को दो पार्ट में सेपरेट करेंगे सच दैट एक पार्ट में लैम्डा आ जाए, एक पार्ट में म्यू आ जाए। आफ्टर सेपरेशन वी हैव टू इंटीग्रल in which first part will have clearly substitution method and second part will be special integral number 3. Second part will have special integral number 3. Yeah. So I'm taking the problem. I have integration of 2x plus 3 into root over 2x square minus 5x plus 6 dx. Yeah. Integration of 2x plus 3 into root over 2x square minus 5x plus 6. इस इंटीग्रल को देख के ही आपको क्लिक होना चाहिए स्पेशल इंटीग्रल नंबर 4. We have linear into root over quadratic. How to start? We will start taking linear is equal to lambda times. We will start taking linear is equal to lambda times differentiation of quadratic plus mu. So now 2x plus 3 is equal to lambda times 4x minus 5 plus mu. Now compare coefficients. So 2 is equal to 4 lambda and 3 is equal to minus 5 lambda plus mu. It implies lambda is equal to 1 by 2 and putting 1 by 2. 1 by 2 is a 3 plus 5 by 2. 3 plus 5 by 2 mu 3 plus 11 by 2. Check करिए. Lambda 1 by 2 mu 11 by 2. Lambda 1 by 2 and mu 11 by 2. Fine. Now we will go back to integral. Integral is integration of 2x plus 3 into root over 2x square minus 5x plus 6. What we have to do? We will replace this linear with expression in terms of lambda and mu, that is lambda times 4x minus 5 plus mu into root over quadratic. क्या इस पे ध्यान दीजिएगा कि जो हमारी लीनियर थी उसे हमें रिप्लेस करना है एक्सप्रेशन इन टर्म्स ऑफ लैम्डा एंड म्यू से. नाउ लैम्डा एंड म्यू हमारा आ चुका है, या पहले इंटीग्रल को दो पार्ट में सेपरेट कर लेते हैं. अब यहां से समझना, मैंने कहा था इंटीग्रल को दो पार्ट में सेपरेट करो. कैसे दो पार्ट में सेपरेट करो? एक पार्ट में लैम्डा आ जाए और एक पार्ट में म्यू आ जाए. दैट हैज मीनिंग हम ये वाला पोर्शन एक साथ रखें और ये वाला पोर्शन एक साथ. रूट अंदर आएगा, इससे मल्टीप्लाई होगा, रूट अंदर आएगा, म्यू से मल्टीप्लाई होगा. सो आई एम राइटिंग लैम्डा टाइम्स इंटीग्रेशन ऑफ 4x minus 5 into root over 2x square minus 5x plus 6 plus mu times integration of root over 2x square minus 5x plus 6. We have got the values of lambda and mu. So now putting values of lambda and mu. Now putting values of lambda and mu. Lambda 1 by 2. 1 by 2 integration of 4x minus 5 into root over 2x square minus 5x plus 6 plus mu 11 by 2 integration of root over 2x square minus 5x plus 6. Okay. So 1 by 2 integration of 4x minus 5 root over 2x square minus 5x plus 6 plus 11 by 2. Now, अब मैंने आपको लिखवाया था क्या कि आफ्टर सेपरेशन इन टू पार्ट्स जो आपका पहला इंटीग्रल बनेगा दैट विल हैव सब्स्टिट्यूशन मेथड. हाउ? लेट्स चेक. ये जो क्वाड्रेटिक आपको दिख रही है इसको अगर मैं t ले लूं तो क्या इसका डिफरेंशिएशन बाहर है? इट विल हैपन एवरी टाइम कि आफ्टर रिप्लेसिंग लीनियर इन टर्म्स ऑफ लैम्डा एंड म्यू एज सून एज यू विल सेपरेट इंटीग्रल इन टू पार्ट्स बाय डिफॉल्ट जो पहला इंटीग्रल होगा उसमें आपको सब्स्टिट्यूशन दिखाई देगा. क्वाड्रेटिक का डिफरेंशिएशन लीनियर. और जो सेकंड इंटीग्रल होगा हाउ टू मेक दैट? देयर वी विल अप्लाई स्पेशल इंटीग्रल नंबर 3. स्पेशल इंटीग्रल नंबर 3 मींस क्वाड्रेटिक को कन्वर्ट करे परफेक्ट स्क्वायर में. सो आई एम डूइंग दैट. क्वाड्रेटिक को कन्वर्ट करना परफेक्ट स्क्वायर में. सो आई एम राइटिंग 2 टाइम्स x plus b by 2a whole square. x plus b by 2a. So x minus 5 by 4 whole square plus c minus b square by 4a. b square कितना होगा? 25 by 4a 8 dx. So and here इसको हम लोगों ने t लिया 2x square minus 5x plus 6 is equal to t. So 4x minus 5 dt by dx. So now 1 by 2 integration of root t dt plus 11 by 2 integration of root over 2 times x minus 5 by 4 whole square. Now take LCM. 48 minus 25 23. Is it? मैंने क्या कर दिया? 48 minus 25 that is 23. So 1 by 2 integration of root t dt plus 11 by 2 integration of root over. Now I am taking 2 common. So x minus 5 by 4 whole square plus 23 by 16. ये 2 मैंने कॉमन लिया तो 2 बाहर आके यहाँ आ गया रूट 2 हो गया. ये समझा? 2 का मैंने बाहर कॉमन निकाला. So now we have 1 by 2 t raised to the power 3 by 2 divided by 3 by 2. रूट t का मैंने इंटीग्रेशन कर दिया प्लस 11 by root 2 इंटीग्रेशन ऑफ रूट ओवर x minus 5 by 4 whole square plus root 23 by 4 whole square. Yeah. So now it is 1 by 3 t raised to the power 3 by 2 plus 11 by root 2 integration of root over x minus 5 by 4 whole square plus root 23 by 4 whole square. Now I am going to apply the formula. Which formula? Integration of root over x square plus a square. क्या होता है? x by 2 root over x square plus a square by 2 log of x plus root over x square plus a square. Now I'm going to use this standard formula here. So now we have this final answer using the formula integration of root over x square plus a square. Here in place of t, quadratic 2x square minus 5x plus 6, and here I have applied the formula. So now in this way, this is our final answer. In books, in answer key, there may be further simplification. तो वो कभी भी आपको ज़रूरत पड़े तो आप कर सकते हो कि यहाँ आपने क्वाड्रेटिक के अंदर एलसीएम ले लिया, इधर एलसीएम ले लिया, देन यू कैन मैच फाइनल आंसर विद आंसर. मैं इस आंसर को अभी यहीं पे छोड़ रहा हूँ. क्लियर? चलिए नाउ आगे बढ़ते हैं. एंड नाउ आई एम कमिंग टू स्पेशल इंटीग्रल नंबर 5. We have special integral number 5. It is integration of x square plus minus a divided by x to the power 4 plus kx square plus a square. क्या पहचान है इस इंटीग्रल की? न्यूमरेटर हैज पावर 2, डिनोमिनेटर हैज पावर 4, where a not equal to 0. Right? A and k both are constant, and I am talking about a not equal to 0. It means k can be 0. If k is 0, then okay, but a should not be 0. So, special integral number 5, it is integration of x square plus minus a divided by x to the power 4 plus kx square plus a square. What constant we have in numerator? Square of that should be in denominator. This integral has some requirement. What are those? Numerator must have power 2, denominator power 4. You find an integral where numerator has power 2, denominator has power 4. You must recall this special integral. In the numerator, power 2 must have some number in addition or subtraction. Square of that number must be in denominator. How will we solve this such kind of integral? Divide numerator and denominator. Divide numerator and denominator both by x to the power 2. Divide numerator and denominator both by x की power 2. Then write denominator x. Write denominator as square of x plus a by x or x minus a by x. Go for term whose differentiation is in numerator. Now apply substitution method. Now apply substitution method. Clear? पढ़िए क्या लिखवाया मैंने? First we will divide numerator and denominator both by x to the power 2. Then we will write denominator square of x plus a by x or x minus a by x. किसका लिखना चाहिए आंसर? जिसका डिफरेंशिएशन आपको न्यूमरेटर में दिखाई दे रहा हो। प्रॉब्लम, इंटीग्रेशन ऑफ एक्स स्क्वायर माइनस 1 डिवाइडेड बाई एक्स टू द पावर 4 प्लस 3x square plus 1. Fine. First of all, check whether it is a special integral number 5 or not. Numerator has power 2, denominator has power 4. Numerator has 1, uska square 1 also in denominator. Yes, it is a special integral number 5. How to make it? Divide by x to the power 2. So, integration of 1 minus 1 by x square whole divided by x square plus 3 plus 1 by x square. Now, numerator 1 minus 1 by x square in denominator. अब इसी को चेक करिएगा, आपको बोला गया डिनोमिनेटर को क्या लिखो, चेक करिएगा आप, समझिएगा अच्छे से। x प्लस ए बाई एक्स और x माइनस ए बाई एक्स, ए कितना है 1, तो डिनोमिनेटर को क्या लिखना है x प्लस 1 अपॉन एक्स, x माइनस 1 अपॉन एक्स। प्लस माइनस में से क्या लेना है, इट विल बी डिसाइडेड बाई एक्सप्रेशन इन न्यूमरेटर। न्यूमरेटर इज 1 माइनस 1 बाई एक्स स्क्वायर। न्यूमरेटर में जिसका डिफरेंशिएशन हो उसका स्क्वायर डिनोमिनेटर में लिखते हैं। न्यूमरेटर में जिसका डिफरेंशिएशन उसका स्क्वायर डिनोमिनेटर में लिखते हैं। बताओ x प्लस 1 अपॉन एक्स का डिफरेंशिएशन क्या होगा, 1 माइनस 1 अपॉन स्क्वायर, और x माइनस 1 अपॉन एक्स का डिफरेंशिएशन क्या होगा, 1 प्लस 1 अपॉन एक्स स्क्वायर। न्यूमरेटर 1 माइनस 1 अपॉन स्क्वायर है, ये किसका डिफरेंशिएशन होता है, ये डिफरेंशिएशन होता है x प्लस 1 अपॉन एक्स का। दैट्स द रीजन डिनोमिनेटर को लिखेंगे x प्लस 1 अपॉन एक्स का स्क्वायर, डिवाइड बाई dx ऑफ x प्लस 1 अपॉन एक्स इज 1 माइनस 1 अपॉन एक्स स्क्वायर। हमारा प्रोसेस कहता है कि डिनोमिनेटर को आप स्क्वायर लिखिए, डिनोमिनेटर को किसका स्क्वायर लिखिए, x प्लस ए बाई एक्स, x माइनस ए बाई एक्स, a is 1, so denominator will be written either x plus 1 by x square or x minus 1 by x square. We have decided to write x plus 1 upon x square. Why? ऊपर जो न्यूमरेटर में दिख रहा है दैट इज डिफरेंशिएशन, किसका डिफरेंशिएशन, x plus 1 by x का। फाइन, वन मोर थिंग इज देयर। अब आपको डिनोमिनेटर में कुछ एडजस्टमेंट भी करना होगा। आपने डिनोमिनेटर को x plus 1 by x होल स्क्वायर लिख दिया। नाउ यू विल हैव टू चेक, is your denominator equivalent to previous one, x plus 1 by x whole square। इसको ओपन करोगे तो क्या आएगा, a स्क्वायर b स्क्वायर 2ab, 2ab के नाम पे कितना आएगा 2, जबकि ऊपर क्या है 3, सो प्लस 1 विल ऑल्सो कम। चेक करिए हमारी एल्गोरिथम कहती है कि आप डिनोमिनेटर को स्क्वायर लिख लीजिए, लिख लिया, बट ओपनिंग द स्क्वायर हमें एक्स स्क्वायर मिलेगा, 1 अपॉन एक्स स्क्वायर मिलेगा, साथ में प्लस 2 आएगा, बट वी वांट 3, तो मैनेज करने के लिए प्लस 1। बोलो, नाउ आई एम गोइंग टू डू सब्स्टिट्यूशन, दैट इज x प्लस 1 अपॉन x इज इक्वल टू t। सो 1 minus 1 upon x square is equal to dt by dx. In this way, dx has value dt upon 1 minus 1 upon x square. Now, integration, substitution and the value of dx. They will make dt upon t square plus 1, which is tan inverse t. So the final answer, tan inverse of x plus 1 by x. Is it? That's our final answer. Clear? सो वी आर टॉकिंग अबाउट स्पेशल इंटीग्रल नंबर 5 जिसकी पहचान है न्यूमरेटर में पावर 2, डिनोमिनेटर में पावर 4 का होना. ओके. One more problem I am taking on this pattern. Now, my problem is integration of root over tan of x. Integration of root of tan of x. अब इसको देख के आपको लग रहा होगा कि यहाँ पे तो दूर दूर तक स्पेशल इंटीग्रल नंबर 5 नहीं है. यस, नहीं है. आई एम स्टार्टिंग द प्रॉब्लम मेकिंग द सब्स्टिट्यूशन tan of x इक्वल टू टी स्क्वायर. राइट. मैंने आपको बोला था कुछ भी ना समझ में आए तो सब्स्टिट्यूशन कर दिया करिए जिससे अंडर रूट खत्म हो जाए. सो tan of x इक्वल टू टी स्क्वायर. नाउ डिफरेंशिएशन ऑन both sides. So tan of x का डिफरेंशिएशन sec स्क्वायर x, t स्क्वायर का 2t dt by dx. In this way dx has value 2t dt divided by sec square x. Clear? Now, integral root over t square in place of dx 2t dt upon sec square x. So, t into 2t dt sec square. tan को क्या लिया था? t square. sec square क्या होता है? sec square x is 1 plus tan square. सेक स्क्वायर को आप लिखोगे 1 प्लस टी स्क्वायर, सॉरी 1 प्लस टेन स्क्वायर. सेक स्क्वायर 1 प्लस टेन स्क्वायर और टेन कितना है? टी स्क्वायर. सो व्हाट विल कम? 1 प्लस टी टू द पावर 4. सो नाउ इंटीग्रल इज 2 टाइम्स टी स्क्वायर अपॉन टी टू द पावर 4 प्लस 1. नाउ स्टूडेंट, फ्रॉम हेयर you have to decide special integral number 5 है भी कि नहीं है. न्यूमरेटर हैज पावर 2, डिनोमिनेटर हैज पावर 4. बट स्पेशल इंटीग्रल नंबर 5 की रिक्वायरमेंट क्या होती है? ऊपर पावर 2 नीचे पावर 4 एज वेल एज न्यूमरेटर में जो पावर 2 होती है उसके साथ प्लस माइनस में कोई कांस्टेंट होना चाहिए विच इज नॉट हियर. बोलो. सो राइट नाउ इट इज नॉट 100% special integral number 5, but if we write in this manner t square plus 1 t square minus 1, then yes, we can have special integral number 5 and not one special integral number 5, two special integral number 5. Now both of these integrals are special integral number 5. 2 times t square can be written t square plus 1 t square minus 1. Now separating integral in two parts. We have 2 special integral number 5. Now we have to complete both of these integrals. So integration of t square plus 1 divided by t to the power 4 plus 1, integration of t square minus 1 divided by t to the power 4 plus 1. What will we do? We will divide by t square. So 1 plus 1 upon t square divided by t square plus 1 upon t square. Divide by t square. So 1 minus 1 by t square divided by t square plus 1 upon t square. Now, न्यूमरेटर क्या है? 1 प्लस 1 बाई टी स्क्वायर. न्यूमरेटर में किसका डिफरेंशिएशन है? t माइनस 1 बाई टी का. डिनोमिनेटर में लिखेंगे t माइनस 1 बाई टी होल स्क्वायर प्लस 2. न्यूमरेटर में डिफरेंशिएशन है किसका, t प्लस 1/t का. न्यूमरेटर है डिफरेंशिएशन t प्लस 1/t. सो डिनोमिनेटर में लिखेंगे t प्लस 1/t होल स्क्वायर माइनस 2. Is it? Now substitution. T minus 1/t is equal to u. So it will give 1 plus 1/t square is equal to du by dt. Here t plus 1/t is equal to v. So 1 minus 1/t square is equal to dv by dt. So from here dt is equal to du upon 1 plus 1/t square. dv is equal to dv by dt. So dt. From here dt is equal to du upon 1 minus 1 upon t square. Clear? So now, after putting the values of dt in integrals, we have du upon u square plus 2 and dv upon v square minus 2. Now it is u square plus root 2 square and it is v square minus root 2 square. Standard formula, which formula? 1 upon x square plus a square. What is the formula? 1 upon a tan inverse x upon a. Standard formula, which formula? 1 upon x square minus a square. What is the formula? 1 upon 2a log of x minus a divided by x plus a. Now, in place of u, t minus 1/t. And in place of v, t plus 1/t. क्लियर? और t हम लोगों ने किसको लिया था? t हम लोगों ने t प्रॉब्लम में स्टार्ट किया था, तो प्रॉब्लम स्टार्ट किया था tan x इक्वल टू टी स्क्वायर. तो t हमारा क्या था? रूट ऑफ tan x. t is root of tan x. So t square minus 1. So tan x minus 1 divided by root 2 root over 2 tan x. ये समझ में? t स्क्वायर माइनस 1. t हम लोगों ने लिया था और t स्क्वायर लिया था tan x को, तो नीचे एक t आएगा और t की वैल्यू रूट 2 tan x प्लस 1 अपॉन 2 रूट 2 log of t square plus 1. So I'm directly writing tan x plus 1 minus root over 2 tan x divided by tan x plus 1 plus root over 2 tan x. Plus c. Clear? So that's our final answer. 1 by root 2 tan inverse of tan x minus 1 by root over 2 tan x plus 1 by 2 root 2 log over mod of tan x plus 1 minus root over 2 tan x divided by tan x plus 1 plus root over 2 tan x. Clear? So special integral number 5. Now student we have special integral number 6. क्या पहचान है इसकी? Denominator has term of sin square, cos square or sin plus cos whole square. Sin into cos. Denominator has sin square, cos square or sin into cos. We will recall special integral number 6. What to do here? Divide numerator and denominator, divide numerator and denominator both by cos square x or sin square x. Then substitute tan of x is equal to t or cot of x equal to t. Remember, if we are dividing by cos square, then we will substitute tan x. If we are dividing by sin square, then we will substitute cot. इस रेड लाइन का मीनिंग समझिएगा what I am saying. We are free to divide numerator and denominator both by either cos square or sin square. But if we are dividing by cos square, then substitution tan x equal to t. If we are dividing by sin square, then the substitution cot x equal to t. Problem: integration of 1 upon 1 plus 3 sin x cos x. How to make it? We will divide numerator and denominator by cos square x. So, numerator sec square x, denominator sec square x plus 3 tan x. Now, sec square x, denominator 1 plus tan square x plus 3 tan x. Now we will substitute tan of x equal to t. So, sec square x is equal to dt by dx. It implies that dx is equal to dt upon sec square. Now, integral substitution and the value of dx. They will give integration of 1 upon 1 plus t square plus 3t. Denominator has quadratic. This will be our special integral number 3. How to complete it? We will write integration of 1 upon t plus 3 by 2 whole square plus 1 minus 9 by 4. So now it is integration of 1 upon t plus 3 by 2 whole square minus 5 by 4. So integration of 1 upon t plus 3 by 2 whole square minus root 5 by 2 whole square. This is standard integral integration of 1 upon x square minus a square. Formula: 1 upon 2a log of x minus a upon x plus a plus c. I have written the formula. Integration is 1 upon x square minus a square. x से कंफ्यूज मत होना, x कहाँ से आ गया, ये मैंने फॉर्मूला लिखा है. Integration of 1 upon x square minus a square, 1 upon 2a log over x minus a upon x plus a. Now here, in place of a, root 5 by 2. In place of x, t. So t plus 3 by 2 minus root 5 by 2 divided by t plus 3 by 2 plus root 5 by 2 plus c. In place of t, tan of x. So 1 upon root 5 log over mod of 2 tan x plus 3 minus root 5 divided by 2 tan x plus 3 plus root 5. That is our final answer. This is our final answer for the problem. Now student, we have special integral number 7. Denominator has term of sine or cos with power 1. Special integral number 7. Before it, we have done number 6. There, sine square, cos square were in the denominator. But here, sine, cos with power 1 in denominator. What will we do? We will use formula of sine and cos in terms of tan x by 2. Sine of x, 2 tan x by 2 divided by 1 plus tan square x by 2. Cos of x, 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Then make substitution, that is tan of x by 2 is equal to t. Getting it? Whenever we have integral where denominator has terms of sine or cos with power 1, what we have to do? Open the formula of sine and cos in terms of tan x by 2 and substitute tan of x by 2 is equal to t. I am taking the problem integration of 1 upon 1 plus sine of x plus cos of x. Here I will use formula of sine and cos in terms of tan x by 2. Formula of sine and cos in terms of tan x by 2. Taking LCM, numerator 1 plus tan square x by 2, denominator 1 plus tan square x by 2 plus 2 tan x by 2 plus 1 minus tan square x by 2. We can cancel. So, integration of sec square x by 2 divided by 2 times 1 plus tan x by 2. Yeah. Now, numerator has sec square, denominator has tan. So, clear cut substitution, and I am substituting 1 plus tan x by 2 is equal to t. 1 plus tan x by 2 is equal to t. Now, 0 plus 1 by 2 sec square x by 2 is equal to dt by dx. So, value of dx from here 2 dt upon sec square x by 2. Now, this value of dx. This value of dx we will put in the integral. This value of dx we will put in integral. So integration sec square x by 2 divided by 2 times 1 plus t, only t, and in place of dx 2 dt divided by sec square x by 2. 2 से 2 cancel, sec square से sec square cancel. So now integration of dt by t, which is log of mod of t plus c. In place of t, 1 plus tan of x by 2. That's our answer. Log of mod of 1 plus tan x by 2, that is our answer. Is it? So we are talking about special integral number 7, where denominator has terms of sine and cos with power 1. Now we have alternative method. Alternative method for integration of 1 upon a cos plus b sine. Alternative method for integration of 1 upon a cos plus b sine, and it is an important one. Fine. अभी हम लोगों ने देखा, for this kind of integral where denominator has cos and sine, what to do? Open the formula of sine and cos in terms of tan x by 2, integral बन जाएगा. But now I am talking about alternative method for such integral. What is that? Divide numerator and denominator by root over a square plus b square. Now convert denominator in formula of sine of a plus minus b or cos of a plus minus b. Then apply standard formulae of integration. Yeah. So problem is integration of 1 upon cos x minus sin x. Integration of 1 upon cos x minus sin x. No doubt we can do this problem opening formula of sine and cos in terms of tan x by 2. But you will find for this problem answer is given following alternative method. Same I am going to apply. Root over a square plus b square. A is 1, b is minus 1. The root over a square plus b square will be how much? Root 2. So I am writing divide by root 2. So integration of 1 by root 2 divided by 1 by root 2 cos x minus 1 by root 2 sin x. Now integration of 1 by root 2, in the denominator I am writing cos pi by 4 cos x minus sine pi by 4 sine x. Now this must be clear to you. Why I have written cos pi by 4 sine pi by 4? Because my intention is to make the formula sine a plus minus b cos a plus minus b. Knowingly I am writing cos pi by 4 sine pi by 4. Benefit cos a cos b sine a sine b. Now it is cos a cos b sine a sine b. So clearly denominator has formula cos of a plus b. Clearly denominator has formula cos of a plus b. So now cos ऊपर आएगा एंड cos ऊपर आके sec बन जाएगा तो 1 by root 2 integration of sec of x plus pi by 4. We know the formula for integration of sec, that is log of tan of x by 2 plus pi by 4. So now 1 by root 2 log of tan of x by 2 plus pi by 8 plus pi by 4, 3 pi by 8. X by 2 plus pi by 8. Now pi by 8 plus pi by 4 मिलके हो गया 3 pi by 8. So 1 by root 2 log over mod of tan of x by 2 plus 3 pi by 8. Getting it? So this is our final answer. Now we have a special integral number 8 where sine and cos are in numerator as well as in denominator. In the previous case, term of sine and cos were only in denominator, but this time we have in numerator as well as denominator. What will we do? Write numerator write numerator is equal to lambda times differentiation of denominator plus mu times denominator plus some delta. Then separate integral in 3 parts. Meaning of separating in 3 parts, एक पार्ट में डेल्टा, एक पार्ट में म्यू और एक पार्ट में आपका लैम्डा आ जाएगा. चलिए, I am taking problem and problem was in exam. It is integration of 5 tan x divided by tan x minus 2. Sin cos में convert करिए तो integration of 5 times sin x divided by sin x minus 2 cos x. Clear? We have term of sin and cos in numerator and denominator both. तो इस प्रॉब्लम को देख के हमें याद आनी चाहिए स्पेशल इंटीग्रल नंबर 8 की. व्हाट विल वी डू? न्यूमरेटर इज इक्वल टू लैम्डा टाइम्स डिफरेंशिएशन ऑफ डिनोमिनेटर प्लस म्यू टाइम्स डिनोमिनेटर प्लस डेल्टा. It implies that 5 times sin x is equal to lambda times cos x plus 2 sin x plus mu times sin x minus 2 cos x plus delta. So 5 is equal to 2 lambda plus mu, 0 is equal to lambda minus 2 mu and 0 is equal to delta. Clear? After writing, we will compare coefficient to get lambda, mu and delta. So 5 is equal to 2 lambda plus mu. Cos का coefficient lambda minus 2 mu and here 0. Now solving it, we can get lambda and mu. So 2 से multiply करो तो 10 is equal to 4 lambda plus 2 mu. So lambda is 2, mu is 1 and delta is 0. Lambda is 2, mu is 1. Lambda is 2, mu is 1. Clear? Now, we will come back to the integral after getting the value of lambda, mu and delta. We will come back to integral, which is 5 sin x divided by sin x minus 2 cos x in place of numerator. Now, lambda times cos plus 2 sin x plus mu times sin minus 2 cos x plus delta and all divided by sin x minus 2 cos x. Yeah. Now, I am separating integral in 3 parts. 3 parts का मतलब separating integral in 3 parts, so lambda times integration of cos plus 2 sin divided by sin minus 2 cos plus mu times integration of sin minus 2 cos divided by sin minus 2 cos, and the third term is clearly 0 because delta is 0. चलिए अभी मैं यहाँ डेल्टा लिख दे रहा हूँ, इसको ऐसा कर लेते हैं, डेल्टा टाइम्स dx अपॉन sin minus 2 cos. Now I am putting the values of lambda, mu and delta. So lambda is how much 2? So 2 times integration of cos plus 2 sin divided by sin minus 2 cos. Clear? म्यू की वैल्यू 1 एंड ये कैंसिल हो जाएंगे तो इंटीग्रेशन ऑफ dx एंड डेल्टा की वैल्यू 0. सो नाउ वी हैव 3 integrals where first one cos plus 2 sin divided by sin minus 2 cos, second is only integration of dx and third is 0. 2 times integration of cos plus 2 sin divided by sin x minus 2 cos x plus integration of dx, x and 0. Now, check this integral. Do we have substitution method here? Denominator का differentiation ऊपर आ रहा है. So now we will do this integral making substitution. That is sin minus 2 cos x is equal to t. So, cos plus 2 sin x is equal to dt by dx, dx is equal to dt upon cos plus 2 sin x. Is it? So, putting the value of dx, now we have 2 times इंटीग्रेशन ऑफ dt by t, मैंने dx का वैल्यू रख दिया और sin माइनस 2 cos t प्लस x प्लस 0. नाउ dt by t हैज आंसर log of mod of t, where in place of t we will take sin x minus 2 cos x. So now our final answer 2 times log of mod of sin x minus 2 cos x plus c. 2 times log of mod of sin x minus 2 cos x plus c. Yeah. So with this, students, I am completing today's lecture. Today we have done total 8 special integrals. In next class, some more special integral I will discuss. Okay.